Mark Barteau did his Ph.D. studies at Stanford University, and he was one of the pioneers in the field of catalysis on surfaces. He has been recognized a lot. I'll tell you a little bit about that in a moment. But he also has distinguished himself in the echelon of a number of high-level administrative appointments. He was the one, he spent part of his academic life at Delaware, where he initiated the Energy Institute there before moving and becoming the senior vice provost for research and strategic initiatives, where he really shaped many relationships between academia, industry, and the community. He then moved to the University of Michigan, where he was the director of the Energy Institute there, and the DTE Energy Professor of Advanced Energy Research and Professor of Chemical Engineering and Chemistry, and the Dow Distinguished Fellow in Sustainability. We were very privileged and happy to welcome here at Texas A&M, where he's now our Vice President for Research, a holder of the Halliburton Chair in Engineering, professor in the Department of Chemical Engineering, and professor in the Department of Chemistry. He received many awards, just to mention a few. In his first part of his career, he was honored with the Alan P. Colburn Award, then the Alpha Chi Sigma Award from the American Institute of Chemical Engineering. He was also received very prestigious award from the American Chemical Society, the Ipatieff Prize, and the Victor K. Lamer Award, both from the American Chemical Society, and also the, just as a token of his international presence, the International Catalysis Award from the International Association of Catalysis Societies. In 2006, he was elected, and he's a member now of the National Academy of Engineering, and he's also a fellow of the National Academy of Inventors. And in 2008, he was named one of the most 100 influential engineers of the modern era by the American Institute of Chemical Engineering. So let us very warmly welcome Professor Mark Barteau, our Vice President for Research here at Texas A&M, who is going appropriately to talk to us about energy and engagement.
Thank you, Stratos. I'm going to... Those of you who know me, you might want to turn the volume down, know that it's a little dangerous for me to be on some platform without all four sides fenced in. So I'm going to speak from down here. Thanks for that warm introduction, Stratos. I'm reminded of a story about a famous Texan, Lyndon Baines Johnson, who after a particularly lengthy introduction said, I wish my parents could have been here. My father would have enjoyed it. My mother would have believed it. So you can't believe everything. It's nice to be able to talk about energy topics. I get to deal with all kinds of things as vice president for research, from runaway horses to dead pigs to all kinds of other export control and other related matters. So I wanted to give a somewhat different talk than you're probably used to this morning. And I wanted to address it primarily to the students in the audience. You've done a great job organizing this conference. And so I want to give you, some perspective that perhaps you might not get elsewhere. And those with, gray hair and gray beards like me can, poke holes in some of what I'm about to say. But really, these are the five messages that I want to get across to the younger folks in the room. And the first of those, and I'll show a few slides to illustrate it, is that the scales and the time constants that characterize the energy and climate landscape look very daunting, We're talking global scales and decadal time scales. And while we can't ignore the realities of that, nothing is inevitable. There have been a lot of changes in the course of, for example, my career. We often see short-term reactions, especially in the political sphere, to various things that capture attention. And oftentimes, those are short-sighted, but the effects linger long after the crisis they were supposed to solve. I think for all of you looking at your careers going forward, obviously, all of us try to walk the walk, and personal virtue is important. But I think one of the things that's important is to find opportunities to have impacts on important societal issues like energy and climate that are bigger than yourself. And those arise, just as the truism about chance favoring the prepared mind, because you're engaged. And I think the other message that I would like to send is that engagement versus scholarship, it's a false dichotomy. Those of us in academia are always doing battle with the research versus teaching, and you can't be good at both. This is another example, I think, of one of those false dichotomies. And so what I want to encourage toward the end of the talk, with perhaps a few personal anecdotes, is that you think about ways, both now and throughout your career, that you can engage in some of these challenges in a way that goes beyond how you conduct yourself or your scholarship individually. So a couple of those sort of daunting slides. And I've got a mix of slides here. Some of them are kind of vintage. I've been giving energy talks for more than a decade. Some of them are updated. But even the vintage ones have useful stories to tell. So, the other message, right? It's not all about technology. And I think that's especially important for those of us in STEM fields to realize that policy and economics can often move the needle a heck of a lot faster than whatever inventions and creative things that we can do in the laboratory. And conversely, if we tend to go out to society and say, we've got the answer to your problem, the response may be, oh yeah. And if you want a shining example, ask your next door neighbor in nuclear engineering. So a couple of the more daunting slides. This is a somewhat old one from ExxonMobil's energy outlook, but I like the graphics. And it shows you mostly the growth of energy consumption in the world since 1800, so over a couple of centuries here. So don't worry so much about the projections. But I'd just like to point out, I was born in here in the mid-50s. And if you look at where we are now, right, the world's energy consumption has gone up 5-fold in my lifetime. That's a pretty impressive number. For those of you who are students, maybe it's only, 50%. For the, associate professors out there, maybe it's 100%. But here it's a 400% increase. And where has that come from? Largely from fossil fuels, right? And you see the historic growth up to here of the oil, gas, and coal contributions to our energy supply. And one of the things to note is, that green bar in there represents a cubic mile of oil. If you want to, ignore the energy units on the left-hand side, if you want to scale these things. Cubic mile of oil per year, that's the world's consumption. So, that looks like a very difficult curve to turn, whatever the projections may be. And of course, the other thing that goes right along with it, since as you can see, the vast majority of our energy supplies come from fossil resources, are the CO2 emissions. And those likewise have gone up by about a factor of 5 in my lifetime. So the challenge going forward is, how do we begin to change the direction of some of these curves? And again, when you think about the numbers here, that seems like a daunting challenge. This is another slide that I think is useful in historical terms. I've tried to find an update of it since 2016, and I haven't found one. But it shows you the price of gasoline since over the last century, and then the inflation-adjusted version. And if you look at that, there's some interesting displacements here. Some of them have triggered significant societal reactions. So this, what looks like a little hiccup here, but was in fact about a doubling of the price at the time, was the Arab oil embargo of 1973. And that certainly produced a lot of angst in this country, concerns about energy independence. If you look at President Ford's State of the Union address in 1975, we were going to build 200 nuclear power plants, 20 synfuels plants. Neither of those happened. We did build a lot of coal-fired power plants because oil and gas were so expensive. And that's the reason now, with the rise of natural gas, that we had a lot of sort of end-of-life coal plants that are much easier to retire than if there were still significant value on the books on a lot of them. This spike in about 1980 was the Iranian Revolution. Both of those events, 73, 1980, produced gas lines in this country. The younger folks in here may have seen pictures of those, but have never experienced them. And then various continuations of this curve on. Right now, we're out here probably, in the low $2 a gallon as the price of our gasoline, which is more on a relative basis, adjusted for inflation, than our maybe for you, great-grandparents paid for gasoline. But certainly these displacements here have, again, provoked societal concerns, political actions. If you look in here, when prices started to spike in the early 2000s, universities started forming energy institutes. Most of them trace their origins back to, about the mid-2000s, as it looked like energy prices were going up, and weren't going to stop. It also produced political responses. So, one of the things, if you think about whether or not we have an energy policy in the US, well, kind of, sort of, depending on the administration. But what do we expect that to accomplish, right? The public wants things like energy independence, although that tends to be a politician's term. We've done polls that show the public really doesn't know what that means. What they want is security and reliability of supply, right? They want energy to be cheap and affordable. They don't want gas lines. They don't want to be paying through the nose for it. They want it to be clean, whatever that means. They want the energy sources and the infrastructure to be safe. They don't like gas line explosions and the like. But you can see just with that look at the last half century or so, how the priorities among those and the way that we define those shift. So that makes it a little difficult to create policy. The other thing that makes it difficult is the responsibilities are spread all over the federal government. So this just shows you all of the agencies of the federal government that have some involvement in the energy landscape, right? So if we tend to think about the federal government as monolithic, it's far from it. And you get competing interests and turf battles, and that also makes it hard to create coherent strategy sometimes. So as we look at the challenges that we're trying to solve, what are they? Well, I've listed some of them here. Certainly the world's energy needs are going to continue to grow as more countries develop. Basically, GDP tracks energy consumption pretty well, although as economies mature, they become more efficient. Clearly, I think a major focus today is on greenhouse gas emissions and climate change, but we also need to think about the impacts of our choices on things like water and land. And so the challenge is to make effective choices that take account of technology and resource limits and economics and policy. And of course, the biggest wild card of all is human behavior, right? I mean, there's nothing, no model in physics that is as idealistic as the economists, starting with the statement, consider a rational consumer. So this is one of my favorite slides because it's got two messages, right? So you have the guy up here like me talking about the importance of different solutions to climate and energy, and a response from the audience, what if it's a big hoax and we create a better world for nothing? That's the joke you're supposed to get. But I think that there's another one hidden in these lists, and that is, yeah, we'd like to have all of these things, but there are trade-offs and conflicts among them, right? So renewables may come at the expense of water and air and rainforests and so forth, how we use our land and water to produce renewables. So this isn't a, you can have all of that wish list, and that's where making effective choices comes into play. So again, digging back into history, this is a slide taken from a talk that John Holdren gave in 2006. Some of you may remember that by 2009, John Holdren was President Obama's science advisor. So this was his view of the energy landscape 3 years before that. And he says, as many of us have, energy policy is hard because there's no technological silver bullet. Nothing is free of liabilities. And so he lists the various sources down here and what limits. And I think what's interesting, again, thinking about the dynamics of this landscape, how even a decade, a little more than a decade later, or even by the time he got into office, some of these ideas had changed. So 2006, you see we're looking at oil and gas, not enough resources. You saw those prices tracking up, up, up. Coal, not enough atmosphere. So here's the sign of the climate crisis to come. Biomass, not enough land. I would argue not enough water as well. Hydropower and wind, not enough places to put it. Probably true of hydro, probably not true of wind today. PV, too expensive. That's something that's changed dramatically in the last decade plus, and so forth. So again, while we can look at these sort of mega trends and think there's no way to sort of turn the battleship, in fact, beneath those are some pretty dramatic turns over decadal timescales. Here's another somewhat historic slide from the Energy Information Administration, 2014. Again, looking at US dependence on foreign oil. And here, the sort of high watermark, 2005, we were importing 60% of our oil in the US, right? That's the sort of thing that got the politicians and the public agitated, that got energy institutes formed. You see it turning around and decreasing, and ignore the projections. These are typical EIA projections, right, which is, you draw straight lines because that's the safest thing to do. But in fact, where we stand right now is that the projections are by 2020 that essentially North America will be a net exporter of energy. So a pretty dramatic shift here. And what's interesting is what Congress tried to make happen and what actually did happen. So in 2007, Congress passed the first major energy legislation in a decade, the Energy Independence and Security Act of 2007, signed by President George W. Bush. And part of the idea was to promote more biofuels as a way to reduce oil consumption, oil imports, and a way to reduce emissions. And here were the projections of how much of an effect that would have compared to the status quo out to 2030. And, some impact, not very big, from biofuels, for example, and some of the other measures. Here's the impact on CO2. And, you know, it's barely the width of the lines if you drew them with a Sharpie. I guess George W. wasn't using the Sharpie back then. Anyway, so that was the sort of thing that you could get consensus around to do in 2007. That has had lingering effects. This is a piece that one of my Michigan colleagues wrote. It's really about how industrial corn farming is ruining both our health and our watersheds, but he published one version of it locally called Cheeseburgers, Biofuels, and High Fructose Corn Syrup Are Ruining the Great Lakes, the Gulf of Mexico, Chesapeake Bay, and Americans' health. And again, because of the industrial scale farming, the impact on our lands, the runoff of fertilizer into our watersheds, and frankly, the questionable benefits of corn ethanol. But as long as Iowa is the first stop in the presidential primary process, that's not likely to change. And you see this debate continuing today. Of course, the thing that really changed the landscape was the shale gale, right? Horizontal drilling and hydraulic fracturing that dramatically increased the output of domestic oil and gas, again, over essentially a decade here of very, very rapid rises. And that's what's changed the landscape more than anything, and had a variety of different consequences. So this is an EIA slide that I've augmented here. You've probably seen versions of this showing where our energy in the US comes from and where we use it. And I think what's instructive here are a couple of things. One, if you look at the petroleum consumption, and again, I've taken numbers from 2009, so 10 and 15 years back. You know, not much change here, fluctuations by plus or minus less than 10% of the average. Natural gas, 23, 23, 31. Huge leap there. We're using more and more gas to generate electricity. Coal from 22 to 20 to 13, and it's headed further down. So big shift there, as we're all aware of, due to the advances on the previous slide. Also point out to you nuclear flat and renewable very nearly doubling over the last 15 years. So we'll look at that in a moment. These are actually some global numbers rather than US numbers showing the growth of wind power over the last decade and solar. And, you know, again, as you think about that exponential growth almost of our energy consumption, we have pretty much exponential growth of both of these as well. There are two bad pieces or downsides, I guess, of this. One is you add, these are actually capacity, not generation. And even at that, they add up to about a little over 1 terawatt. And the global energy consumption these days is, about 17 terawatts? I haven't looked it up lately. So making a dent, but need to make a much bigger dent. Another lesson, I think, as one looks at that growth, is something we tend to forget about, which is the fact that there are experience curves, learning curves, and the costs of things tend to come down dramatically the more we make them. So this is a slide that hasn't been updated since 2011, but showing you how the cost of photovoltaics has come down as a function, this is a log-log plot, as the number of solar modules produced. And if you think about it, and I'm getting emails on a weekly basis offering used solar panels for 10 cents a watt, right? That's down here on the x-axis. We're out here now. If you think about John Holdren's comment from 2006, right? You know, we were looking at dollars per watt, and now we're at least an order of magnitude lower in the costs of these. And we need to remember that can happen with other technologies and on the same time scales as well. The other bit of bad news is that while those dramatic growths of solar and wind have occurred, And you see here the increase over the last decade. In fact, we still are seeing pretty persistent growth of our fossil resources as well. So this is not coming at the expense of fossil yet, and that presents one of the challenges for dealing with climate issues going forward. So I've gotten a little ahead of myself here. Let me turn back the clock once more. This is a slide from Steve Koonin, who was #2 in the Department of Energy during President Obama's first term. So this is a slide from February 2001. So again, 8 years ago, this is how the Department of Energy was framing the energy challenge at that time, right? Still concerned about energy security, mostly about transportation and liquid hydrocarbons, the goal to reduce our crude oil use. I'm not sure that's actually happened. Greenhouse gas emissions, thinking mostly about CO2 from stationary sources, targeting modest reductions in the near term, but pretty dramatic reductions by mid-century. And certainly you see a lot of policy that was targeted at that, and a lot of progress here, but again, largely due to replacement of coal with gas. And then significant changes in energy supply. That's happened. Transmission, maybe not so much. Storage, certainly in use. And then you get the usual Washington speak, cost-effective material, timely solutions, and jobs, 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 right? So that's never missing. And so the way that the policy got framed at that time was thinking about dividing the world really into 4 parts. Stationary and transportation, right? This is where we use oil. Electricity is largely, stationary. That's where we use almost everything else. And then both the supplies and the demand side. And you see things like deploying clean electricity. And again, realizing that this is also where renewables tend to feed in, thinking about things like electrification of the vehicle fleet. How do we get advances here to affect the transportation side of the equation? This was 2011 in the first Obama term. In the second Obama term, I think you saw more climate issues coming to the fore. Continue investment in renewables, research, development, and deployment, and things now that the current administration has been doing their best to eliminate: the Clean Power Plan, the corporate average fuel economy standards tightening, and the Paris Accords. And so just to shift a little bit to the CO2 side and the emission side of things here. This is a plot that I've augmented, taken from a National Academies report, looking at the average fuel economy of the U.S. transportation fleet, and then projecting that forward and the kinds of technologies. So this is internal combustion engine, hybrid electric vehicle there, that it would take to meet that. And the right-hand side is the inverse. It's miles. This is the gallons per mile, which is the better comparison, miles per gallon over there. So one of the first things you see, looking at the blue line, right, between 1980 and the mid-2000s, our average fuel economy flattened out and even went in the wrong direction. Anybody know what happened in there? SUVs happened, right? So they were exempted from the CAFE standards. What did the vehicle manufacturers do? Well, they made lots of exempt vehicles, and we love them, right? If you go out in the parking lot here, you'll find probably more than half the vehicles are SUVs or trucks. I do know, by the way, that every time I go out to Los Angeles, my observation is the Prius to pickup ratio is exactly inverted from College Station. Anyway, and then you see the CAFE standards. This is the one that the Trump administration has relaxed, but achievable really with fairly modest improvements to internal combustion engines. These are, really not revolutionary things that we're trying to be done here. The other thing to realize is because of the impact of natural gas on our electricity generation and of renewables, the CO2 emissions from transportation in this country crossed over and became greater than those from electricity generation more than 3 years ago now. So whereas you saw the 2011 plan from the Obama administration saying CO2 was largely about stationary sources, in fact, this is the real and bigger challenge. Well, they're both real challenges, but that's the bigger challenge today. A couple of comments about CO2 that I think people probably don't realize. Over on the left side are the sources, burning fossil fuels, land use changes, but where it goes, and the message here is that the land and water and plants of the planet are only able to take up about 56 or 7% of the CO2 we're emitting. Right? 44% of it's going up into the atmosphere and stays there. And so if you look at things like our atmospheric concentrations of CO2, right, that's the integral of the curve I showed you at the beginning of how emissions had climbed. And so we're now at the point where we're well over 400 parts per million of CO2 in the atmosphere. And again, going back to where I was born in here, that means I'm breathing in about a third more CO2 than when I was a child. So that's one of the challenges is the integral there, and how do we begin to turn that curve? You may have seen pictures like this. This is an animation you could find on the web. I wasn't able to port the animation. But showing you global average temperatures by month since 1850. And it's when you see the animation, it's pretty impressive. You get this spiraling cyclone and the divergence out here. And at the maximum excursion from the average, we're already near, well over 1 degree Celsius on average above the 1850 to 1900 average and getting dangerously close to 1.5. But you can almost see think of this as being shaped on a potter's wheel, that same exponential curve of CO2 concentration defining the cross-section. What do we do about it? Certainly, we need to reduce emissions. I think there's a growing realization of the need for what are referred to as negative emissions technologies, ways to remove CO2 from the atmosphere and keep it locked up. This is taken from a report I'll reference in a minute from the National Academies, looking at sort of what the scale of these negative emissions technologies would need to be, assuming that we're able to reduce dramatically our burning of fossil fuels and our emissions, but still needing, some of those will remain. It's hard to get rid of all of them. What do we need to do in terms of pulling CO2 out of the atmosphere to get us down to net zero? And this particular slide is for the Paris goals of 2 degrees C. You can slide this at various other places on the curve. I think the Shell Sky scenario puts it at 2070. Is that right, Joe? And I think New York State is aiming for 2050 net zero. But the point is, we're going to need ways to suck CO2 out of the atmosphere by 10 to 20 gigatons per year globally by mid-century and up to 20 by century's end. And so I had the privilege to serve on a couple of National Academy studies in the last year looking at how to meet these challenges and what research and what investment, what development we needed to be doing. And we looked at a variety of things. This is using the mangrove swamps and things like that in our coastal regions, which we refer to as coastal blue carbon, improved agricultural practices, reforestation, direct air capture, so removing CO2 directly from the atmosphere chemically and mechanically, sequestration and mineralization. And, you know, one of the things is we certainly have some opportunities to use the natural world to suck up CO2, but not at the scales that are shown there in the previous slide. You know, right now, the direct air capture area is kind of in its infancy. There are a couple of companies you may have heard about, Carbon Engineering, Climeworks, that are making money at this. But we're seeing more and more attention to this, more and more startups every day. And again, we need to remember it may not be economical today, but remember those learning curves. The more we do, the cheaper it will get. And part of the way we can do that is by tilting the economics, and I will say here and now, we must price carbon in some way if we're going to solve the climate problem. We can do other things as well. The second report looked at utilizing some of that captured carbon, and likewise methane emissions from things like landfills and so forth, and turning it into long-lived products that will tie the carbon up for long periods of time. The challenge here is if you look at chemical conversion, for example, our entire chemical supply needs only about 10% of our total oil and gas consumption, maybe less. So we don't have the scale of products that we could possibly make there that would take a larger bite than about 10% out of the CO2 sequestration apple. But there's still things that we can do. So I wanted in the last part of the talk to shift gears. You know, I talked about engagement at the beginning, and just to give you some personal anecdotes and observations about, Stratos mentioned the various jobs I've had. You probably think I can't hold a job. But things I've learned in the course of that may or may not resonate, or may resonate differently with different of you. One of the things that I had a chance to do early on was to help bring a wind turbine to the University of Delaware's coastal campus. At that time, there were no offshore wind turbines in the US. And so this one was put about a baseball throw away from the shoreline. It was as close as we could get without getting our feet wet, but very much a marine environment where we could study the effects of ocean water and salt and things like that, as well as generate enough power for that campus and the surrounding community. So that's been going not quite a decade now. And I think one of the lessons from that, it's one wind turbine in the state of Delaware. It's not huge. But one of the lessons was you can find opportunities in your own backyard to make progress, and you should take them. And I'll just throw out one here at Texas A&M, especially on a day like today. How many of you, when you're parked outside, put the screen on front of your windshield to keep your car from cooking? Why don't we build carports with solar cells on the top? Other than our hail problems around here, I think this is a tailor-made spot for doing something like that, keeping our cars cooler and at the same time generating significant amounts of energy for the campus. Oh, and by the way, the cost of doing that goes down every day. Another opportunity that was certainly foundational for me was chairing a task force of the Governor's Energy Advisory Council that produced the energy plan for the state of Delaware about a decade ago. And so I was asked to chair the Reducing Environmental Footprint Working Group. And I had been a department chair in the university, which is, the chairs and heads will tell you is like herding cats. But this was a whole nother dimension. We had 24 members, including vice presidents of the local utilities, as well as Sierra Club members. We were subject to public meetings laws, which was new to me. And in spite of that heterogeneity, we were able to come up with 11 consensus recommendations for the state energy plan. One of the ones I think what I learned more from was one of the ones that we couldn't reach consensus on, And that was, at the time, Delaware's renewable portfolio standard was 20% by 2019. And there was a lot of, a lot of interest in increasing that. And the reason was that the utilities actually had contracts for offshore wind. We were absolutely sure, at least the citizenry of the state, that Delaware would be the first state in the union to have offshore wind. It still doesn't, by the way. And in fact, that project got canceled about 2 years later. And so, you know, there were a couple of lessons from that exercise. One was, with enough work, you can achieve consensus among different constituencies and different interests. But, you know, it's important not to assume the best case scenario. The utilities may have had contracts with this nascent wind firm, but they were very skeptical about whether or not that would come to pass. And in fact, they turned out to be right. So they reasonably resisted being forced into dependence on making that come true. When I got to Michigan, one of the things we did was to organize a workshop in Washington, D.C. on shale gas and U.S. manufacturing. And I think we produced a report. It actually got highlighted by Bloomberg, and recognizing that the availability of low-cost shale gas could catalyze a renaissance in U.S. manufacturing. And I think we've seen that in the last 5 years. It was already in progress before that, but certainly has happened at a scale greater since. And, you know, our attempt to balance the economic benefits and the environmental and public concerns. In fact, the biggest lesson that I learned from that exercise was that the manufacturers, the steel and chemical and glass companies that were relying on the shale boom, their biggest concern was that the reliability of supply because of the potential loss of societal license to operate of their suppliers. They were worried in 2014 about a wave of fracking bans sweeping the country. That has largely diminished, although it hasn't completely gone away. But it occurred to me that this was not that different from the apparel industry, right? Consumer demand forced companies like Nike and others to kind of clean up their act with regard to their suppliers, their labor policies, and all of that. And I think this is an industry where we haven't seen that as much. But certainly, you know, as we think about different ways for the public to exert influence on the companies at various parts of the supply chain that lead to consumer products, it struck me that even in this industry, perhaps the story wasn't all that different. One of the other things we did at Michigan was to create a survey, an energy survey, asking the public attitudes about reliability and affordability and environmental consequences of the energy supply. And that had some very interesting outcomes. This is looking at energy costs and what the public might see as unaffordable. And looking at terciles of income, in fact, what we found was that the lowest third and the second third were pretty similar, and then there was a gap up to the highest third of household incomes in the country. So when it comes to energy costs, there's no middle class. The other thing was what people said would be unaffordable, that would really force them to change their habits. And while they may complain about, you know, a quarter or 50 cents at the gas pump, you know, what they were telling us was gasoline would have to be over $5 a gallon before they would change their behavior. So here's the human behavior part of the equation as well. Another question that we asked them, well, you know, what we've seen is pretty cheap gas for now 5 years, and what the public has largely done is use the savings to buy bigger, less efficient vehicles. We asked what they would do if gasoline became unaffordable, and this was the responses: use different transportation, drive less. 20% or so said drive smaller, more efficient vehicles. The interesting thing was when we looked at that response by income level, in the lowest third of income levels, that choice was half that, only about 10%. And so, the message was that the capital cost of changing one's mode of transportation, of buying a different car, was a significant barrier to become more efficient, much as we have seen things like insulation and low-cost housing. And so I think one of the lessons there is, yeah, the average is important, but we need to realize how individuals are affected by these things, how they respond, in particular, how their circumstances may lead them to different responses. Probably running out of time here. One of the other projects that we tackled was looking at Michigan's renewable portfolio standards. When I got to Michigan in 2012, there was a ballot initiative to raise the renewable portfolio standard to 25% by 2025. And it went down in flames. And the public debate was just an orgy of mudslinging. So, you had groups like the Michigan Environmental Council saying it's going to cost you, $1 a month if we do this. And you had the front organization for the utilities saying it's going to cost the state $12 billion and thousands of dollars in higher electric bills for Michigan families. So what was the truth? And people didn't know what to believe. So this failed miserably. And so one of the things that we decided to do when the furor died down was to say, well, what do we think the real number is? And did a very thorough analysis. And our conclusion was that to have gone to 25% by 2025 would have raised the average utility bill in the state about the price of a cup of Starbucks a month. Would have increased the cost of manufacturing a Ford in the state of Michigan by $10, right? And that was assuming no progress in wind or solar technology and prices. Interestingly enough, the state, 4 years later, did raise its renewable portfolio standard even with a Republican-controlled legislature. The increase from 10% to 15% was certainly behind the national average, but ahead of neighboring states like Ohio that suspended their RPS. But the interesting thing about that was that the cost piece of this had largely disappeared from the argument, that everyone, including the utilities, was beginning to accept the idea that this would not be that costly, and the debate turned much more on principles of how much government should mandate. So, but in between that time, and I don't think we deserve a huge amount of the credit for that, but I think one of the lessons was to take advantage of times when, the political winds aren't blowing hot and heavy, when things are out of the spotlight, to perhaps lay the groundwork for more intelligent conversations and policymaking in the future. Okay, so I wanted to say a few words about public engagement as well, something I've had the opportunity to do. Some of you may go on to that, maybe not. We had a meeting to look at academic engagement, public and political discourse, and I love to show this slide because looking out from the podium, that's sometimes what the audience looks like, right? This is outrageous, I completely agree, and all of that, it's a sea of monsters. By the way, that's the way most assistant professors see their first day of class at the university as well. And as I think about those things, engagement with the public, engagement with the press can be frustrating, but I think it's rewarding. It's nice to get your name in the paper. Sometimes it's important not to get your name in the paper. Sometimes it's important to provide the information to reporters that helps them to realize they don't have a story there. I think I've had the chance to be interviewed a lot of times by reporters from all over. I've shown some of the stories here that I've been privileged to be quoted in. But I show this in part to draw another lesson. About 2.5 years ago, I was quoted in Time magazine about whether coal could be brought back, and this was the quote. Coal is not coming back. It's going to continue to lose to cheap natural gas. I think that's continuing to be true. But anyway, that's what you get, what is it, a dozen words or so in Time magazine. Here's what I got on the same topic in the Süddeutsche Zeitung, which is the main newspaper in Munich, Germany. So literally paragraphs addressing not just the economics, but the climate impacts and the moral aspects. So it was an interesting lesson about the depth of coverage in the press in the US versus some of the international sources. And one of the reasons that I've found it gratifying in some cases to interact with reporters from some of those, from other countries as well. You know, I think if you do go the route of public engagement, it's important to provide perspectives and opinions. If you want to be seen as an honest broker, it's important to avoid advocacy and especially pushing specific policies. That doesn't mean one can't provide perspectives. I've had a chance to do some both for the conversation that you may be familiar with and for Fortune, a couple of them here. And one of the messages here, again, is that there are a lot of different ways to have impact. So if I look at the 5 articles in the conversation, I don't know what the count is for Fortune because they don't track it. Those are over 55,000 reads. You know, my scientific career, published about 250 papers, got me into the National Academy, 15,000 citations. So the message is, you know, that's important, but one can actually have very big impacts, and I wouldn't say that's necessarily a really big one in other spheres as well. So that's the concluding message I want to leave you with. There are many ways to have impact. I've really enjoyed the opportunities I've had in my career, and I hope, again, for the students out there, the young people, you will think about the ways that you can have impact, not just through your scholarship, but the way you engage your profession, your peers, your communities, and the community and political processes. So thank you very much.